Okay, guys, so in this case, we have got another typical exam question on our trigonometry. So we are going to consider these typical questions. So that was a question number 6. Calculate the values of theta that will satisfy the following equation. Okay, these are values of theta and angle theta. For you are supposed to be given the interval, like I said before, from a certain interval. They were given from 0 to 360, and this is our equation, which is our trigonometric equation. The disadvantage of the trigonometry is that we do not have much. This is what we just given on your formula sheet. Just like what I said on your logarithms, these are topics that you need to understand. You need to know them by heart because you have got fewer things like on your formula sheet. All right. Anyways, let us consider this. That's a trigonometric equation that you're given. The 6.1, we are given a 0.5, the cos of theta plus 0.5, which is equal to 0.7. All right, so this is the idea. Whenever you are working with the trigonometric equation, it's a cos, it's a sine, it's a tan, whatever that you're given, you must have a single trig ratio. So from this, what we need is to obtain a single trig ratio. A single trig ratio is, as you can see, there's a cos here. So you're supposed to have this as the subject of the formula. That's a single trig. So you're supposed to make first, you have to make it the subject. If it was a direct, like the sine of theta is equal to 0.5, from there we just calculate the reference angle. The reference angle is equal to the arc sine. We know that. It's a single trig. That's why we simply calculate the reference angle. But in this case, this is not a single trig. So you have to make cos the subject. So that is to make cos the subject. So you're going to make cos theta the subject. That is the first thing. Let us make cos theta the subject of the formula. What is it that is affecting? There's a 0.5 which is adding. We can transpose this to the right-hand side so that it can be a negative. So you've got 0.5. The cosine of theta is equal to, you subtract 0.7 minus 0.5. That was going to be a 0.2. Then you are still having something affecting the cos of theta, which is the 0.5. As a product, how do you remove the product? You divide. So dividing by 0.5 both sides, thus the cosine of theta is equal to this, which is the 0.4. So if you have to divide this, you're going to obtain 0.4. Okay. Like I said, what you need is a single trig, which is the one that you're having, a single trig ratio, that is to make cos theta the subject. And there we have the cos theta being equal to 0.4. So what is going to be the reference angle from this? As you have a single trig, what you're going to do is to find the reference angle. In this case, the reference angle. So the reference angle is simply the angle, the acute angle. It's the acute angle that you determine from removing this cos, so that you have got the theta. So it follows that to write the cos on the other side, it is going to be the arc cos, which is arc cos 0.4. So arc cos, that is simply shift cos on your calculator. So whenever you are working with this, what you need is to find arc of the sine, of the cos, of the tan, whatever trig that you're given there. Okay, so this is on your calculator. Let us just try and simplify this. That is the arc cos, which is shift cos 0.4. So you're going to have this 62.42. So depending with the question that you're given, maybe you're given to 3 decimal places. So it is best that you shift this, fix this. So that is shift to the fix on number 6, then to 3 decimal places, that will be 66.422. So that is the reference angle. So the reference angle, what it does is that it is the acute angle So whether it was a negative there, you ignore the negative, you work with the positive. So always you must have this reference angle as a positive. That is, if you ignore the negative sign that you're given. So the question is, what is this positive representing? Because whatever that we had previously here does not matter. What matters is where we have the single trig here on the cos of theta. This is the stage that matters. At this stage, we can see that the cos of theta is equal to 0,4. And what does the 0,4 represent? It's a positive value. So being positive, it matters because remember from your quadrants that if you're given this from the cast concept, if you are given this cast concept, or the all students take calculus, we know that this is the quadrant for all trigonometrical ratios being positive. This is the quadrant of a sine being positive, the tan being positive, the cos being positive. So in this case, we are working with the cos, and our cos is a positive. So meaning to say the resultant, the answer that you're going to have, which is the equivalent that we must have, must be taken one where cos is positive. So working with the cos is positive in this quadrant and also in the first quadrant for all. This is for sine, this is for tan. So we are not going to take this, we are going to take the first quadrant and the fourth quadrant. So the question is, how are we going to take the actual solution from the reference angle that we are given? Theta being the exact angle that you're supposed to calculate. In the first quadrant, it is equal to the reference angle. If it was in the second quadrant, remember this is 180 degrees minus the reference angle. If it was in the third quadrant, it was going to be 180 degrees plus the reference angle. In the fourth quadrant, it was going to be 360 degrees minus the reference angle. Each and every quadrant that you're given has a relationship to the reference angle that you calculated. So in this case, we said our cos is positive. So the answer is supposed to be taken in the first and in the fourth quadrant. So focusing with the first quadrant, it follows that therefore our theta is equal to the reference angle in the first quadrant. Theta is equal to the reference angle that we calculated, which is 66, we are now having the exact answer that we got before. The reference angle as it is from the first quadrant. What about the third? Because the theta that we are taking, remember, it's from 0 to 360. Within this, it's from 0 to 360. Which are the angle that we're going to have? In the fourth quadrant, cos is also positive. And in the fourth quadrant, x is equal to, so considering theta is going to be theta, all right, let's just have this as theta. If it is x, you're going to consider x. So if this is theta, as we are given, theta is equal to 360 minus the reference angle. So that means in the fourth quadrant, the other solution that we're going to have for theta was going to be 360 degrees minus the reference angle. And our reference angle is what? 66,422 degrees. That is how you can answer this question. So there we have got our theta. All right, so our theta in this case was going to give us 293,578 degrees. So we've got two angles to consider, theta being 66,422 degrees and other theta being 293,578 degrees. So these were the two possible values of theta within the interval that we are given from 0 to 360. So you must be given this interval whenever you've got a question to solve a trig equation. All right, 6.2, we are given a fig to consider, which is fig 1, and that is our fig 1 in this case. All right, a supervisor must train a new team of loggers. All right, to estimate height of trees as an example. She walks 12 meters from the base of the tree and estimate the angle of elevation to the tree's peak from the base. We can't say this is the trees. It's a, remember the tree, guys. It's a vertical presentation. So this is your tree. So we are having an investigation that is happening. Estimating from B, which is the foot or the base of the tree, to this point, you see we've got 12 meters. The angle of elevation was seen to be 62 degrees at the peak of the tree. So this is the peak. We are looking at the peak of the tree. Determine how tall is the tree. This is the tree. So how tall is the tree? Guys, whether you were understanding this information or not, by just knowing that this is the tree AB, how can you determine the length of AB? That is the question. How can we determine the length of AB? All right, remember from our trigonometrical ratios applying the SOHCAHTOA concept. This is a right angle triangle that we have. So working the SOHCAHTOA concept, which is giving us the ratio of the sine, the ratio of the cos, and the ratio of the tan. According to the triangle that you're given, you want to calculate the length of AB. This is the height of the tree. So focus on what you are to calculate and what you are given. These are the two things that you focus with. You want to calculate the length of AB according to the angle of 62 degrees. What is the side AB representing? Side AB is the opposite according to the angle given. If the angle was here, you work with the angle that is at this point. So working with 62 degrees, the side that you're focusing with, AB, this one, is the opposite. It faces 62 degrees. So we have got the opposite. What about the 12 meters? This side is the adjacent side. Remember, guys, this is the hypotenuse, the one that faces the 90 degrees. So the last side is the adjacent. The one, the angle and the 90 degrees they are adjacent to each other. Don't focus with AC. There's nothing that you need. You end up confusing yourself. These are the two things that you focus on. What you need to calculate, which is AB, and what you are given, which is 12. This is the opposite. This is the adjacent. There is only one ratio of these three mnemonics that we have that will answer this question, where there is opposite and adjacent at the same time. That is the tan, opposite, adjacent. So the ratio states that the tan of theta is equal to the opposite over the adjacent. So you can fill in what you are given. The tan of theta, theta is the angle, which is the angle of 62 degrees, is equal to the opposite, which is AB, over the adjacent side, which is 12. All right, so this is same as over 1. You need to solve for AB, remember? So you're just going to cross multiply. 1 multiplies AB, 12 multiplies the tan of 62 degrees. So 1 times AB, that is AB, is equal to 12 times the tan, that is 12 tan 62 degrees. So this is you and your calculator. Simplify this. So as I said, you can even fix your calculator to 3 decimal places, depending with the instruction that you're given on the question paper. But that is a direct simplification on your calculator, just 12, then tan 62 degrees like this. So remember, our calculator is fixed to 3 decimal places. So that is, we're going to have 12,569, 22,569. So AB, the length of AB is 12,569 meters. Remember, this was given in meters. So this length also is going to be in meters. Take note of this. Take note of this information that you're given. Take note of this information that you're given. AB represents this AB that we are seeing here, represents the height of the tree. How tall is the tree? So therefore, we can conclude that the tree is 12.56 centimeters, 12.569 meters high. That is the height of the tree. These are the typical questions that you might be given in your examinations. 6.3, it was a continuation that you're given. Use the calculator. This part, use the calculator to simplify this. Okay? That is 6.31, 3 sine 12. This is supposed to be 12 degrees. All right. Then we have got 42 minutes. So these are minutes. So this 12 represents degrees. Okay. Then we have got 4 tan 42 degrees. So this is you and your calculator. You can just even simplify everything direct. You can simplify the top. You can simplify the denominator. This is up to you. All right. So since this is already fixed to 3 decimal places, let us just see on our calculator. So like I said, you can even simplify the top part, divide, or just simplify direct. So this is 3 sine. All right. So 12 degrees. These are degrees. These are minutes. So if you check on your calculator, there is this button just after the minus here. There is a degree. The first dot that you're seeing is the degree. This one is the minute. Then the other 2 is for the second. So if you see this one on the fact B, this one, there's degree, minute, seconds. So you press 12, then you press this. This is to show degrees. Then 42, you press it again. So to press it, it is now representing minutes. So do not worry, because your calculator is not going to show properly the minutes unless depends with the calculator that you're using. But know that the first one, as you pressed it, it was in degrees. The second one, as you pressed it, it will be in minutes. If you were to press again, it will be seconds. All right, let's say there was another value in seconds. All right, then this one is 4 tan 42 degrees. This one, there's no need for you to even indicate that degree and minute, just 42 as it is. The calculator already knows that this is what this is in degrees. Unless you want to put that, does not affect. All right, so this is it. We're going to obtain 0.83. So like I said, you could have simplified the numerator on its own, the denominator on its own. All right, 6.32, again, to use a calculator. So you can even simplify, that is this part under the square root there. That is 9 cos, so that is under the square root. There's a square root, 9 cos 360, cos 360 degrees, like this. So this one is going to give us 3,00, which is just 3, plus there is a 1 here. All right, minus 1/2 sine squared. This is in radians. Whenever you see the pi, this pi that you're seeing there, it is an indication that you're dealing with the radians, pi radians. So it's either you're going to convert it to degrees. Remember, pi is 180 degrees. So you're going to write this as 180 degrees over 3, because it's pi over 3. So you also divide by what? You also divide by 3. So this is going to give us 60 degrees. So this is minus 2 sine squared pi over 3, which we converted, or you can even write as it is. You converted maybe to degrees is sine 60 degrees. How do I present this on the calculator? All right, let me just put the minus here and just focus with the 2. How am I going to present this on a calculator? On the calculator, it means 2 sine 60 degrees. Then you square you square the sine as it is. Okay, this is what I'm trying to say. This is our calculator. Let us save our calculator and see. So remember, we fixed our calculator So that's why it's giving us decimal. Sometimes you might not even have a decimal. So you can even go back to the normal mode, shift, you go to the setup, 8, then you can press 2. All right, so this is what I'm trying to have. As long you have the degrees, just open the bracket. So this is 2, open the bracket, the sine of 60 degrees. So the calculator opened a bracket for 60 degrees. This is the part of the calculator on its own. Close that one for the calculator. Then close the one that you opened here. Remember, there's a bracket here that you opened. So you close it. Then you square this. You have squared the sine of 60. This is what it means. So you're going to obtain 3 over 2. So that was going to be minus 3 over 2. So this is it. You can even simplify everything together. 3 plus 1 minus 3 over 2. So this was going to give us 5 over 2, or as a decimal, 2,5. So you can write this as 5 over 2 or just as 2,5. So these are the typical questions where the calculator is needed. They need you to use the calculator. They want to see how do you apply or how do you use the calculator at the end. So more questions to come from Maison African Motives till we meet again.